Funda. So in this video, we are going to tackle a classic linked list problem using Java, right? So this is a Leetcode problem, merge two sorted lists. That is a problem number 21. So in this part of the FAANG preparation in 180 days playlist, where I have already uploaded several medium level problems focused on arrays and string. So these problems are designed to teach you a core DSA techniques and problem solving patterns. So if you are interested in mastering approaches like sliding window, two pointers and other fundamental strategy, be sure to check out the videos from week 1 and week 2 of 6-month FAANG preparation series. So this is the next question on the top of more important videos in this playlist. So I'll request you to go and watch those videos if you are preparing for the FAANG. So let's ahead and understand this question, problem statement, and lot of things that we are going to do in this video. So the problem statement is saying that like you are given heads of two sorted list 1 and list 2. So your job is to merge these two lists into one sorted linked list by splicing together their existing node and return the head of the merged list. Okay, so pause this video and go through the statement, right? Okay, so let me read this question. So you are giving the heads of two sorted linked list 1 and list 2. So, and then we are saying that merge the two lists into one sorted list. The list should be you can say made by splicing together the nodes of the first two lists and return the head of the merged linked list. Okay, so let's understand by example. So example, it is saying that we have given 1 2 4, then list 2 we have given 1 3 4. So if in the visual, if you see, this is 1 2 and 4, this is one list 1, and this is list 2 similarly. Okay, so it is how it is coming the output like this, right? So it is saying if you will merge this, right, you will see like this. Okay, how this is working we'll talk. So what actually it is doing, this is the list 1 and this is the list 2, right? So list 1 node first this data and this data, it is checking. Okay, so this is not greater than this, right? So what will happen, this will come first here and then this will go here, right? If it is 2 is greater than 3, right, then we will not do anything. But if 2 is less than 3, then we will put 2 first and then the 3 will go later, and similarly for the 4. Okay, now understand, if the list is empty, right, then you will provide the empty. If some list 1 is already empty but list 2 have 0, then we'll provide list 2. So the number of constant we have given is the number of nodes in the both list in the range of 0 to 50. Means maximum node value can be greater than equal to minus 100 and less than equal to 100. Both list 1 list 2 are sorted in non-decreasing order. So if you have gone through the problem statements, right, and you have paused the video, then you clearly understand that what is the problem is here. So let's understand the background of the question, right? So what question is saying that you are giving two linked lists, right, each already sorted in non-decreasing order. Means non-decreasing means what? Increasing order. Okay, so your task is to merge these two lists into a single sorted linked list, right? Means your task is to merge these two lists into a single sorted list, and you should do this by reusing the existing node. Okay, you should do this by reusing the existing node, whichever we have, that we have to use, not to create a new nodes, right? Because if we will use the new node, right, the space will be get created, and that is not good for a programming, right? So no new node creation should be there. Only we have to take the existing nodes and we have to put into here, right? And so we have to return the head of the new merge list. Okay, now you have understand the problem, right? means no new node creation should be there. Only you have to check from here and here. If this is less than, it will go into the new linked list, right? Sorted linked list, okay? And if it is greater than, we'll keep it like that only, okay? What is the constants we have given? So each list can have up to 50 nodes, and nodes range is between -100 to 100, and both lists are sorted, okay? So if you are reading the question, right, just assume that you understand the background clearly, right? So here, what is the background here? Means no new node creation should be there. This should be in your mind, right? Okay. Then the constants, what are the constants we have given, right? So if you are thinking about, let's suppose the uh, brute force approach, will my brute force approach will work or not, right? Like that you have to do, okay? So as I explained this problem statement and the problem background, so this is simple, right? But what's the most efficient way to do this? Okay, that we will see. But before that, let's understand the intuition and the thought process part. Okay, so what is the intuition is here? Since the input lists are you can say already sorted, so we can take advantage of this. Think of this we have a merging two sorted list, like a two sorted array we can say. So if we are merging the two sorted arrays, okay, so we will compare the smallest element at the front and we'll keep appending the smaller one to the our result, right? So this is like that we have to think, okay? So this is a great case for using the two pointer technique and one pointer for each list, okay? You pause this and go through the intuition, okay? So what intuition is saying that since both lists are already sorted, right? If both lists are already sorted, we can use the two pointer technique, right? If you have already watched a lot of videos, right, that I have already uploaded in this playlist, you will understand what is the two pointer technique, okay? If not, let's understand. So first of all, we'll compare the current node of both side, both list, right? So one, we'll keep the pointer on the current node, and we'll keep checking the list of value of node 1 in the list 1, and similarly with the list 2, okay? So when we'll compare the current node of both list, right, let's suppose we were seeing that the first list was 1 and second list also have the 1, so 1 we are comparing, right? So the first step is saying compare the current node of both lists, then append the node with the smaller value to the result. Then we'll move the pointer forward in the list from which we took the node, and continue until both lists are fully traversed, right? Means first we will compare both list nodes, right? The current nodes you can say, and we will append the node with a smaller value to the result. So there is a result linked list, right? And where we will append that node whichever is having the smaller value. Then further what we will do, we'll move the pointers in the list from which we will take the node, right? So if the node pointer is at the current, once we have compared that, we have choose the smaller value to the result, then further we'll move the pointer forward in the list which we took the node, right? And continue until both lists are fully traversed, right? So it's easy, right? So if you'll talk about the possible approaches, right? So now before jumping into the code, let's look at the possible approaches why we are using why we are choosing you can say our particular solution. Suppose if you'll go for the brute force, if you'll go for the recursive, if you'll go for iterative, right? So think about the brute force. So put all the values in an array and sort it and build a new list that's inefficient. That will take what? O of n log n, right? So if you will insert all node into a new list and sort it at the end, right? You will get what? O of n log n. And that is why brute force approach is not good for us. Think about the recursion. So recursion is elegant but can cause a stack overflow for very large list. So if you are doing the merge by recursively by choosing a smaller heads, right? So the recursion is elegant, right? This is good, right? But it uses stack space. So if it is using stack space, it means this is also not better, not good. If we have the better one, right? So there is an approach that is called iterative approach. So iterative approach, we will use a dummy node and loop through both lists and will always connecting the smaller node. Okay, this is simple, efficient, and will use a constant extra space, right? So when we will do merge using the loop, and there should be a dummy head, right? So we will use this technique, this approach, and we'll say that it is good for space efficiency and good for clarity. Okay, so we will use here a dummy node and a loop, and through both list we'll always connect the smaller nodes. Okay, so let's continue to understand the iterative approach. Before that, we have to understand how in the background two list works. Okay, so let's suppose we have the list 1 1 3 5, list 2 have 2 4 6. So these two are linked list 1 and list 2. Okay, so the technique was, if we are comparing this one with this 2, which one is a smaller, 1 or 2? So in this case, list 1 having the smaller data, right? So what will happen? We will create a dummy node and set it to the current here. We'll compare 1 and 2. If 1 is less than 2, so we will append 1 into the result, and this is called advanced list, right? So result dummy will point to a node. Okay, further we'll compare 3 and 4, 3 and 2. This 3 and 2 will compare. So once 3 and 2 will compare, we'll see 2 is what? Smaller one. And so this 2 we will append into the dummy head. So dummy has already one node, and then we have another node. So what we will do, we'll provide the head of the next node to this node 1, and so the result will keep added into the dummy node, and so the dummy head will keep created as a list, right? And so this list we will return finally in the result. So let's continue to understand how when the 3 and 4 will come. So you have already added 1 and 2. Now it's time for comparing the 3 and 4. So 3 in this case is smaller, and so we will append into the dummy next head, right? And the dummy will become what? 1 2 3. Similarly, we'll compare 3 and 4. 4 is smaller, we add into the dummy and we'll move ahead. Okay, then we will check about 5 and 6, which one is smaller? 5 is smaller one, right? So we will add here in the dummy result, dummy list, and finally we'll have 6, right? So list 1 is full now, right? List 1 is full now, so we will append the 6 directly to the, you can say, dummy, and so your dummy become 1 2 3 4 5, right? So this points to the connection, means this node is connected to this node, this node is connected to this node. I think you are aware of that. So the dummy, when we'll reach here, we will return dummy dot next, right? And what is the dummy dot next? Which is 1, right? This is the head of our merge list. And so if you'll talk about the iterative solutions what we have given. Okay, so let's understand, right? Let's walk through the Java code that we have created. So let's understand what is this. So first we will create a dummy node. This will help to create the head of the result list. Okay, so this we have given means first we have given what the class we have given, and that we have to return in the node list, and we have merge to list. So merge to list having list 1 and list 2, right? So first of all, what we should do, so the step 1, we will create a dummy node to act as a start of the merge list, right? Means we will create a dummy node first, and this will help us to handle the head of the result list. So this dummy node simplify handling, you can say, edge cases such as empty input list. Okay, and then we will have a current that will always point to the last node in the merge list so far. So how we are going to define like this. So first of all, the placeholder node value doesn't matter, but you can directly write list node dummy equal to new list, and we'll add 0 in the node. Okay, then list node, as you remember, right? If dummy having data, will do dummy node dot next and will return it, right? So there will be a current. So current node we will point directly to the dummy. Okay, so when we will do dummy dot next, we will return it. Okay, so current will keep changing, right? And for that, the pointer to build a merge list, we have very important node that is called current node. Let's understand the next what we need to do. So in the first step we will create a dummy node to act as a part of the merge list. Then we'll say this dummy node will simplify the handling edge cases such as empty input list. So if any list having the empty, let's suppose list 1 and list 2 are inputs, right? So these list 1 and list 2 are empty. So in this case, what we will do, we will return this dummy directly. Okay, let's understand the step 2. So in the step 2, what we will do, first we will traverse both list while neither is fully traversed, right? So list 1 and list 2, if this is not null, then in this case we will do the merge, right? What we will do, the step 3 will compare the value at the current node for both list, and then we'll check if the list 1 dot val is less than equal to list 2 dot val. Then what we will do, if the list 1 node is smaller or equal, link it next in the result. Current dot next equal to list 1 means what we will do here, first we'll check the list 1 dot val. If it is less than the list 2 dot val, means we will compare which one is the smaller one, right? So in this case, let's suppose the list 1 having the smaller value, right, or equal to, so we will link it into the result one. So current dot next equal to list 1. So current was pointing to the you can say dummy. Now current dot next, we have data is list 1. Okay, then we will move to the next node in the list. So how we are going to do, so we'll do list 1 equal to list 1 dot next, and then if the list 1 val is not less than equal to list 2 dot val, means the node from the list 1, if it is not less than list 2 node value, right, it means less than equal to not, right, then in that case it will come to the here, means list 2 have the smaller one. So what we'll do, the current dot next, we are pointing to what, list 1. So in this case what we will do, right, means we will use the node 2 value. Then what we will do, current dot next will become list 2, right? This was a smaller one, current dot next was smaller at where, here. So what we will do, when a smaller list 1 having the smaller node, then we were pointing to the list 1. Now the current dot next having the smaller one. And what we will do, we'll provide the list 2. Similarly, we'll move to the next node in the list 2. So list what we will do, list 2 is equal to list 2 dot next we will do, and we'll move to the next node. Then we'll move to the current pointer forward in the merge list, right? What we will do, we'll merge the current node, current pointer forward in the merge list. So current equal to current dot next, and then we'll keep moving ahead, right? We know that, right? So if you recall, right, if you see here, right, so first part we'll compare the step 3 is very important. Okay, actually to traverse that list should not be empty. In the step 2 we will create the while loop, but step 3 will compare if step 1 having the list 1 and list 2 no empty data, right? So list 2 is no empty data. So let's step 3 will keep checking which node having the smaller one. If a smaller is list 1, will go in this condition, else will go in this condition. But in both cases, once the step 3 is done, what we have to do? We have to go for the step 4 to move the current pointer, right? Either you're going into the next, the first list 1 and list 2, then again you have to move to the next next pointer, right? Where is the current? At list 1 first node or list 2 first node. If both is done, now we have to move to the next one, right? Means current we have to update. Current is from where we are going? Current is from the dummy list, right? So we have got the next value. Current we have assigned already, right? Now we have to, once you got the current value, now you have to move to the next value of the current. Means we are trying to build that, right? So to build that list, we need what? Current. You understand, right? So dummy, what was there? Dummy dot head, right? Dummy dot, current was where? At dummy, right? So we have started from what? Dummy or having the 0 linked list, right? 0 node, right? From there, what we have done? We have assigned the current. Then which one is a smaller one? That will come to the current, right? Then what we will do? We'll move to the current dot next. Like that, the current will keep all the nodes, right? Let me tell you. So this is current. So first what we have done? We have compared this and this, right? So which one is smaller one? This one. Means it will go in the if condition. If it is greater, it will go to the else condition. But this is current. So current, once you have added from the list 1 here, current should move to the here, right? And so when will current will come here, we have to calculate again. So we'll check the next value, 2 and 3 will check, right? Which one is smaller? Means else condition is smaller. So we'll get the else value. Like that, we'll keep doing that and we'll build the dummy, right? So your current will point to here. Once the current dot next having the data what? Null. It means we are done. Okay. And then we'll return what? Dummy dot next will return finally, and will your dummy dot next is you have the all the data, right? So first we have created the dummy node, right? Current we have assigned to the dummy, right? And then what we have done? Then we have traversed both list. Then we have compared the nodes value, current nodes value, and we have updated our current dot next will go on the list 1 or list 2. Finally, once your current dot next is updated, now you have to update the current, right? So current will become what? Current equal to current dot next. After that, one of the list may still have remaining node. So if let's suppose list 1 have one node, but list 2 have 3 nodes, though, then what we will do? The next 2 node will left. Then all those node, right? What we will do? If it is not null, right? We will directly assign on the current dot next equal to, if it is list 1 is null, we'll provide the list 2. Otherwise, it will provide list 1. Okay. So in this way, we will return the merge list starting after the node, like we will return dummy.next, right? I hope you understand, guys, right? So there is a iterative approach that we have discussed. Okay, there is a recursive approach. Let me know in the comment section if you want to understand the recursive solution. We have seen already the iterative approach. So iterative approach is an optimal solution, right? Because it takes O of n times and space is O of 1 time. But in the recursive solution, it will take O of n times. So I have provided the solution here. You go through that and let me know if you have any doubt. Okay. So what is the conclusion here? For this problem, the iterative solution is generally preferred due to its constant space complexity. So the algorithm efficiently merges the two sorted lists by traversing them once, make it an optimal solution. Okay, so that is why this is good solution. So please pause this and read it. Okay, thank you guys. Thank you for watching this video. Let me know if you have any doubt. Please subscribe this channel, support it, and keep questioning if you have any doubt in the comment box. And don't forget to like the video if you have already subscribed. Thank you guys. Thank you for watching this video.